Good morning. Today is September 9th, 2017, and this is the John Chappell Natural Philosophy Society Saturday morning science chat. And please come and visit our website at www.naturalphilosophy.org. And you may also come and visit our forums to discuss things. And we're also on Facebook. So today, I think we have a couple topics from the people who are attending our meeting today. So I wanted to kick things off first with Hans. So Hans has been sending me some emails about what he feels are basic structures. So Hans, could you go ahead and describe what we're talking about there?
Well, it is the following. About 2.5 centuries ago, scientists have discovered the wave equation. It's a second order differential equation, and it has some solutions. Among them are waves, and that's the reason that the equation got that name, wave equation. But it has also other solutions, and these other solutions only occur in odd dimensions. So since we cannot go higher than 4, it occurs in 1 and in 3 dimensions. The one-dimensional solutions are shock fronts that I have given a name, warps, and they in fact are the parts of a photon. A photon is a string of these warps, shock fronts that are emitted at equidistant instances. And these warps keep their amplitude when they are traveling. So they keep, in fact, their energy. So they can be sent over billions of light years and still have that same energy. And but the shock fronts themselves don't have a frequency, so they have to be emitted as strings, and then they got a frequency when they are emitted at equidistant instances. Those are the things that constitute photons. And the three-dimensional, the spherical shock fronts, I've called them clamps, and they have a tiny bit of mass. And these clamps are triggered by isotropic triggers, a landing of a hop. If something is hopping around in the embedding continuum, then the continuum is starting to vibrate with a spherical shock front, and that integrates, the shock front integrates into the Green's function of the continuum, and as a consequence, that continuum is a tiny bit deformed. So the clamps have a standard tiny bit of mass. They are the smallest, the most tiny objects that exist that have mass. And an electron, for example, is consisting of a billion times a billion of these tiny particles, these tiny objects. These tiny objects form a swarm, and the swarm represents the electron. So the electron itself is a point-like particle, and it is hopping around in a hopping part. And after a while, that hopping part has formed a swarm, a hop landing swarm. And that hop landing swarm is representing the complete elementary particle, the electron. That's the idea of the electron. So the smaller structures that appear in reality are not yet discovered by physics. Physics has neglected them, And on the other hand, they exist already for 2.5 centuries as solutions of the wave equation.
Is it a non-linear wave equation?
It is a second order. It's linear. That is a second order wave equation.
So I mean, if it is linear, then it is hardly to get the soliton kind of solution, right?
In fact, the warps are solitons.
How do you pronounce? Could you spell the name?
W-A-R-P. But it's a name
Warp, okay.
Yeah, it's a name that I have given to the thing because they didn't have a name. Nobody gave them a name beforehand.
It looks to me similar to the soliton waves.
Yeah.
Those waves discovered in the water of the sea water, ocean water in Boston, some maybe a couple hundred years ago, and then later it turned out that they come out as a solution of a non-linear difference equation. It's kind of a combination of linear and non-linear effects and so and so.
Yeah,
so on the other hand, I had heard that Laplace had a kind of non-linear wave equation, not only linear one that we know, the Laplacian, the second order derivative over space dimensions equals minus second derivative over time, but kind of non-linear. I was looking for that, I couldn't find anything regarding that. So my point was actually that such effects could be only a result or solution of non-linear different wave equation.
No,
whatever form it could be of it.
It is a perfectly linear equation, and it's a second order differential equation. And therefore, maybe some people may think that it's non-linear, but it is a linear.
No, it's linear. It's linear. If there is kind of no, it's essentially. I don't know. I mean, that's Laplacian, the second order space derivative, can be actually represented as a curl of a curl, minus sign, plus something like gradient of divergence. Yeah. So that part, gradient of divergence, is essentially recognized as something that can produce the longitudinal waves.
Yeah,
and that's something that is missing in the conventional Maxwellian electrodynamics. On the other hand, actually, when you look into the heterodynamics, you can get one can realize actually the presence of non-zero divergence of electric and magnetic fields in vacuum itself, and then out of that one can look for solutions of that kind, and then there can be actually those scalar or longitudinal waves that have been unofficially, indirectly recognized, at least by designing those kind of containers for plasma, kind of really physical structure. So this is a little kind of paradoxical situation that on one side it is the technology is there based on that, and on the other side such ways are not recognized in the
but this is. These are vibrations of our living space, not the electromagnetic field, but in fact the same as gravitation fields. That it's the space in which we live is a field, is a continuum that can vibrate and can deform, and that field, that is the carrier field of these warps of the photons effect. Everybody says that photons are electromagnetic waves, but that's a complete error. Electromagnetic waves exist and photons exist, but they are different things.
Yeah, I also was forwarding such an stance that actually there is no any fundamental similarity between photons and electromagnetic waves. So electromagnetic waves would be of the kind that is something that is related to induction, That's kind of induction-based waving of the medium, the way you have also those non-zero divergences and so on. And the photon itself is kind of already preformed configuration that actually then just partially may excite the surrounding medium to produce certain amounts of waving, but essentially they are particles because of the high density of its very core part of the kind of toroidal vortex shape.
Yeah, the electromagnetic field is a pure field. It can exist in space as well. These two fields, the gravitation field and the electromagnetic field, exist in parallel. They can vibrate and they obey the same kind of equations. Their differential equations are similar, only the boundary conditions are different. But in fact, these fields obey the same kind of equations.
Well, I think that's going a little bit far, saying that like light waves are different than radio waves. They do appear very different, but we do see a continuous spectrum all the way through the electromagnetic spectrum, which includes light.
Yeah.
So wouldn't you think that kind of points out that these must be the same phenomenon?
The problem is that those things that can behave as particles also have probability waves, and these probability waves, they control where the particle can be. So they also look like...
Yeah. Look, but this is kind of for quantum mechanical constructs, this kind of probability density function. If you replace the probability density function by really density distribution function, you would get then the dynamical structure. It's something like, there is no need to look really kind of into what to say. I really kind of at the moment forgot. So it slipped out from my mind. So maybe I get back to it later.
The wave function of small particles is in fact a probability function. It describes the probability distribution of the electron or of the quark or of all these small particles have a probability distribution that says where they can be or cannot be, or whether probability to be able to
this is kind of quantum mechanical view, but actually its physical interpretation can be through the densities, to the velocities, and so on. And I wanted to maybe respond to Franklin's question regarding frequency. I mean, similarity between waves, electromagnetic waves, and photons. Actually, photons always go in pairs, minimum in pairs, and then as trains of those pairs. As already said, sorry, could you? What is your name? I mean, the person that opened kind of discussions here. Could you repeat your name? I kind of.
My name is Hans van Leunen.
Okay. So, as you mentioned before, actually, the frequency of photons, or actually frequency of trains of photons, is kind of related to separation, right? Separation of those pairs of photons that get emitted from particular source, right? So if you look at only frequency, that would mean anything that would show some important fundamental similarity between photons and electromagnetic waves, right? Because their nature is totally different. And frequency, if it's photons, is just kind of a measure of repetition of those pairs of those structures.
Yeah.
Do you agree? Yeah.
The frequency is in fact determines the distance between the warps that constitute the photon. And in a wave you have wave tops, and they also determine the frequency of the wave. And so far these things are quite similar. So you can use the same kind of formula to a large extent for both phenomena, but they are quite different in structure.
Yeah. Yeah, so I agree with that. And by the way, I have a bunch of your papers. I mean, kind of in my backlog for reading. Actually, you are very close to. I mean, kind of when I mentioned before the scalar waves, longitudinal waves. I think in your papers you have it, right? You created that theoretical framework. You are also working with the quaternion algebra, right?
Yeah, that's true.
So it would be good if you could bring something kind of enlighten us with those aspects. You know, to what extent now then maybe quaternion algebra could help us in this kind of understanding or maybe extension of Maxwell equations in general. You know, kind of the relevance for physics. Why Hamilton did it in the first place?
What I did is I've constructed a Wikiversity project, and I put together everything of these theories together in a complete project with a central page and about 16 subpages in which the
Yeah, yeah.
whole of the theory is put together. And one of these pages are, and three of these pages are completely devoted to the quaternionic differential calculus that describes all kind of waves. The
Yeah.
differential equations of all these fields are in fact the same. So you can use the same kind of differential equations for the gravity field and for the electromagnetic field and for waves of the sea and the ocean. They obey the same kind of mathematics. And the quaternionic mathematics is rather easy if you use the quaternionic nabla. Then the formulas are quite simple.
So you have it like reports of the Hilbert book model project, right?
Yeah,
Oh, yeah.
that's the Hilbert book. I'll put the link. I will put it in the chat on the site as soon as I get a chance. But
Well, I did want to get back to our email here. I'm showing you the email that you sent me initially on September 2nd. Now, what interests me about this is, you know, you say like many theories of physics basics start with a space filled with basic structures.
Yeah.
And that vortexes and toroids are applied, and that the theory must be able to generate those basic structures. So I thought that was a fundamental truth there.
Yeah, but the structures do not come from nowhere. They either must be created by something, or they must be regenerated each time that they are in use. But they do not come from nothing. A toroid must be generated, or it must be created at the start of the universe.
Yeah, that's why
Yeah,
I generally rally against vortexes, because I can't see how something that complicated could spontaneously form.
It's not actually. I think I have provided enough kind of inputs for really understanding the way those I would say vortex-shaped flows appear. I was talking about that about the smoker's ring structure.
Yeah.
If you imagine, if you imagine a container full of smoke, tobacco smoke, right?
Yeah,
and you put that guy or that apparatus to produce those smoker rings, and you play with them. You will see how they get formed, how they interact with each other, and so on and so. So really, there would be nothing mysterious about that. About stability, that depends. You know, smoke ring in the smoke container would have a much better, stability and longer life than in the situation where you make that smoke ring in the air, for example. And the ether, a totally similar situation, but on different scales. You have a very high pressure and so on and so on. So kind of my question here would be kind of maybe for Marlene. I mean, in principle, in such forms, those dynamical forms, those actually are forms, described by flow of particles of ether, of particular fluid. In this case, one question. So we have movements both around the ring and around the toral parts, like equatorial, let's say, or and meridional. And we have those movements in both directions. So we have four options. Equatorial, that can be related to the electric field, and the meridional, that can be related to the magnetic field. They interact by forces 1 over r squared and 1 over r to the third degree. And then we have, two signs, two, directions. And the equatorials have kind of same configuration, right? Kind of really. So, what would be the way to relate equatorial algebra to such toroidal structures, dynamical structures? What is the link, and how it could be? I assume you have it already in your papers, in your works, right?
The differential equations, the first order differential equation, the quaternion differential equation, contains curls, and it contains divergences, and it contains time derivatives. In fact, the first order differential equation has 5 terms. And all these 5 terms control different parts of change of the field. And this is already in the first order differential equation. The second order differential equation that I talked about, the wave equation, only contains the divergence and the time derivative part. So it doesn't contain any curl. It's a curl-free equation.
But kind of, quaternion algebra is kind of extension of vector algebra, right? Combination of vectors and scalars. And then in one operation, one can have has actually all of them. I mean, kind of both gradient and divergence and curl. So when you say there is no curl, kind of something strange.
It's a second order equation, doesn't contain a curl term. Sorry.
This discussion's getting out of hand. I don't think a lot of people, I don't know whether Slobodan knows what a quaternion is.
I know what it is, and I'm pretty enthusiastic waiting to get.
Well, it might be helpful to explain it. Plus, I have a basic question here at the very get-go, which is what assumption you say many theories of physics start with a space filled with basic structures. What is space?
Space is you can have a parameter space, that's a flat space, and you have the target.
I mean, you're making a physical assumption here, and then when I asked you the question, you started making mathematical assumptions. Yeah. What is the physical assumption that relates to the mathematical structure that describes it?
In physics, you have 2 kinds of space. That's parameter spaces and target spaces of functions, which are called continuums.
Those are mathematical concepts.
Yeah, but they are also physical concepts.
Your basic assumption is that physics is mathematical.
That is not my basic assumption.
Well, you need to lay out what your assumptions are, because I'm completely confused.
I think mathematics is derived. Mathematics is derived by
the definition of space in mathematics is completely different than space in physics.
No, it isn't.
Yes, it is.
No, it isn't.
Okay, prove to me that you're right.
I cannot prove because the mathematical space is not measurable, and the physical people say, well, what you can measure, that is true, and what you cannot measure doesn't exist.
So in other words, basically,
if you keep that, then the discussion ends.
So you have to make an assumption, and you need to state what that assumption is.
Yeah, let me try to describe what is happening. The scientists have looked at reality and saw some basic structure and phenomena in them. And they built a kind of mathematics regularity that they call mathematics. And then they found out that with that mathematics they could describe physics. The mathematics, most of the mathematics is completely derived from the regularity, the structure that was observed from reality. So these two things, to a certain extent, are exactly the same things.
That's an assumption on your part.
No, that's not an assumption.
Yes, it is.
Without mathematics, I cannot describe physics.
This is
I
John
could
in
I could
Houston.
describe I could describe and think and believe that actually those the kind of physical approach and the mathematical approach can converge to each other and I mean support each other definitely. So I mean
That's still an assumption on your
in
part.
particular quaternion algebra may really help in kind of how say relying on or supporting the how say the vortex formation as a basic structure in nature. And to get to that structure physically, I mean, it's really not that difficult. I mean, kind of, I had tried to explain that, I mean, a couple of occasions. So if we imagine, for example, that we have a flow of certain particles in all directions, and how say, so it's a tropical and homogeneous. You know, they how say collisions would necessarily form the tetraeders as the only stable structures. They're actually Platon's tetraeders. The tetraeders of that kind formed intermittently will be necessarily be pushed to each other by the flow of all other particles, by that pressure, whatever, how we can term it. And then the next structure is a combination of 5 of those. Such combination is something pentaeder or something like that. I'm not sure about the name. In such structure, there is a gap of some 17 angles or so. So such structures then are getting pushed to each other and then tend to form the elongated structures. And those gaps get aligned and got be hit, and that structure, the elongated structure, start how say rotating about a long axis, and as such they create gyroscopes. The gyroscopes hitting each other precess by Navier-Stokes equation. You get actually the formation of torial vortex.
Oh, I find that hard to believe.
I mean, you can find, you can hard to believe. It's not about believing, you know. I mean, it's not about believing. It's about kind of, you know, kind of combination about physics and mathematics, and if support each other, then you know we are just fine. Everything fits.
No, that goes against the fundamental laws of thermodynamics. I mean, everything gets more random.
Okay, get it. So, second law of thermodynamics is not, tenable. So, it was actually that in this situation that I mentioned, you had the maximal entropy, right? But still, out of that, you get structuring. And those those structures actually get colder than the environment. And even exchanging the heat with the environment. You know, that's a big issue, a very, very important thing, maybe most important thing to start from. And people in different areas, from different aspects, actually are already touching that pretty much, you know. It's not considered a secret anymore. I mean, in principle, for open systems, again, the second law of thermodynamics is kind of defined for so-called closed systems, right? But there is no closed systems, and we look into universum, we have to deal with the open system. And this open system is actually, I just described the mechanism how the high entropy gets converted, gets reversed. So out of that, you get reduced entropy. And reduced entropy means structuring. I mean,
I just don't think that's.
You guys, we have really to try somehow to little bit unlearn and somehow really get off the box and somehow, you know, how to say, I mean, look into. I mean, it's nothing about what I'm talking about. It's nothing about that I just came to it. It was really something that I came to serendipitously, kind of eclectically, you know, starting from some maybe just side kind of insights through special theory relativity and so on, so on. So somehow, I'm really telling you, there is a lot of around, a lot of results and support out from what we really can build. I mean, and come to what every decent scientist and philosopher was striving for and was hoping and how say, being sure that something like this is possible. The total kind of universality, the uniqueness of principle on all scales. I mean,
no,
higher than that. Higher than that. I don't think that the humanity would be of how say of need to do anything in next 10,000 years. I mean.
Well, I mean, this is what is so hard to believe about what you're saying. I mean,
so I'm not. Please don't believe. Just look. I have provided enough information. So documents, books, translations of chapters. Okay, 2 papers.
Well,
and
I know that
just 2 papers, and those translations that I provided would be enough, you know, really for us guys who are interested, really, who are aware of the difficulties and critical of bad situation, terrible situation in physics and science in general, to get to the right track.
Well, I think this is Hans' point. This is his main point in his initial email, that, you know, I've read the stuff that you've produced, but, you know, largely the toroids are postulated for people who have toroids. Those are just said to exist. Now, I know you're trying to justify that, but logically, it still doesn't make any sense to me.
Franklin, as I've told you before, you need to understand mathematics, and you don't understand mathematics. So please, you know, I wish you would stop saying this.
Everybody understands
I
some kind
criticized
of
you the
mathematics.
last time you said this. Okay, a toroid is a mathematical structure that exists in mathematics. And now you claim that it doesn't exist in nature. Okay? Now that
no, I make no such claim.
Hold on, stop.
It gets created in nature and is available in nature on many scales, including the smoker's ring.
Yeah,
please think about smoker's ring within the container with smoke, tobacco smoke under high pressure.
Right.
Think of it. Make that. Play with that. Everything will be clear to you.
Yeah, if I can imagine a room full of smoke, and in no way will a toroid ever form in that. I don't care what.
Put a smoker or that apparatus, that very simple apparatus that produces smoker's ring. Put it there. Put 2 of them.
The thing that produces the smoke ring is a very complicated structure, and something has to be driving.
I just described how it naturally emerges from just moving, from just maximum entropy, physically.
No,
and look at this. Through the mechanics of gas, you have everything. You please contact some of colleagues from the mechanical engineering departments. You know. Please find someone some people who are dealing with gas mechanics and dynamics. Talk to them.
And they
exchange your stances, your inputs, ask questions. You will get it, you know. It's very simple and something that all of us have been kind of avoiding in our careers. I'm not for myself. I really think that most of us are on that.
Well, this is the hard to believe part.
Don't believe. Look at it. Just look from that point of view.
Well, we know what.
Franklin, it's not your position as moderator to express your belief. That's not your position as moderator.
Well, actually,
that's not your job.
Franklin is right. Everybody understands enough of mathematics to, at least in this the community is smart enough with mathematics to understand what the toroid is and what a point is and what a line is and all those things. So some mathematics everybody understands, even a child.
We are not talking about that. We are not talking about that mathematics. We are going about dynamical equations that can describe as a solution such forms.
But
sorry for interrupting.
But what you didn't do is describe how these primitive structures are generated. Something must generate
Well, you
these
didn't either,
primitives,
Hans.
even
You didn't
these
either in your
points.
theory, huh?
Say God,
Yeah.
say God made those particles, how say, zooming all around in all directions, homogeneously and isotopically.
If
And
you
then
look at
start from there and consider that for every next scale, the structure that got formatted in certain way on the lower structure becomes a particle for higher scale of reality. And you go and you get kind of grand recycling, you know. And then, okay, I mean, I mean, really, we should not go really into details and really ask for all explanation. But if we would like really to go into the kind of issues of infinitesimals of you know, kind of high and low infinitesimals, then we can go back to the Descartes, Leibniz, and Cantor, right? Take Cantor, take his philosophy and mathematics of infinite and so on and so on. I mean,
yeah, but that
if we look at those basic structures as kind of basic elements of mathematics, you know, then we will get to different mathematics in a way, and you know, and then things could be, well, how say, more receptive and kind of maybe I mean, we can just start from certain scale and with certain assumptions and see what that gives and check with the reality, you know, and see how it differs from what we have now.
These structures can be generated in a solid state, in crystals, and in liquids and things like that. But try to imagine how these structures can be generated in free space. And
There is no free space. There is no. Somebody asked, "What is space?" Space is just kind of flow.
no, it isn't.
Okay, it's too much. I mean, my point is, we don't have to go. I mean, if we just ask all the time on how this and how come, how this, I mean, we have really kind of that would bring us to nowhere. You know, we have somehow to differentiate, how say, comparatively, what something of that kind, something new, brings compared to what is already in place in science and so on, and then compare them against the nature, against the physical results, against the experiments or whatever, you know.
Well, what would be the most simplest space filled with basic structures? Now, I would think that, you know, the most basic thing you could have would be like a particle.
Please stop.
Okay, presuming
The
that
most-
we
the
have
most-
What do you mean
particles.
by
The most
space?
basic space that there is a
Stop.
number system.
Stop.
A number system is
What
the
do you
most
mean by
basic
space?
space
A
that we
number
have.
system? That's
Yeah.
not space.
A number system
That's
is
not
space.
space.
It's exactly.
So,
Okay, that's an assumption on your part.
No,
That's
you
an
use it
assumption on your
as
part.
soon as you write a formula or so, and an equation.
Equations describe space, but it's not
and-
actually space. I mean, there's a distinction there. When you talk about mathematics, mathematics can describe the results of experiments, but equations are not the actual thing.
If you're going to talk about space, then you have to start with a number system. If you don't do that, you
Actually, if I was a mathematician, I'd say you have to start with a topology.
yeah, but that.
but if
But
you know,
if it's a metric topology, then you have a parameter space, and
Okay,
that's
now
the
you have an
most
assumption that
simple.
you're dealing with a metric topology.
you know, you actually the point is to combine topology with the dynamics. You know, to get dynamics, to get modeling that dynamically creates those structures in topological sense. What do you think about that?
Well, I think Harry wants to get back to an intuitive idea of what space is. Now, I think
No,
from
that's not,
people's
please.
well, from
Please.
May I
a,
offer a definition of space? May I offer a definition? May I offer a definition of space? It's a perceived reduction in density of a specific material in a given environment, and that can be mathematically quantified. But whether it's space in your room, whether it's the reduced density of air particles outside a gravitational environment, or reduced amount of planetoids in a given environment that we call outer space. It's a perceived reduced density of a specific material in a given environment. That's the definition of space. Because at the same time, there can be energy, particle waves, things that you're not counting in that perceived density.
Well, that's an interesting definition, but the issue here is, in my opinion, the first sentence that says many theories of physical basics start with a space filled with basic structures. So I want to know, I think that statement really should say with a mathematical space filled with basic mathematical structures.
Well, I think it should start with a physical basis, starts with a space, which is a physical thing, which contains the only property it contains is the ability to be measured as a distance. And it contains three of those dimensions, three physical dimensions of X, Y, and Z.
So you're saying it's a mathematical thing.
It's not a mathematical thing. It's something that I would intuitively refer to as empty space. That all it is a region where it can contain things like particles, but there's actually nothing that makes up space. I mean, we've had a lot of email discussions about this. Some people feel that the space must be filled with some material substance, so that it's like a sea. So that's one way you can see space. That space is actually a physical structure made out of discrete particles. Or you can think the opposite, which is that space is that same kind of region except containing nothing at all. So I prefer to think that at the first level, you do have space which does not contain anything. But on top of that, it is filled with structures which we recognize as electrons or positrons. But it so completely fills that space that it might as well be like the space that other people are talking about, which is physically filled with a substance. But and this is where we get into the ether theories, because the etherists believe that space is in fact filled with this ether. And then we got into the philosophical discussion of what's between the particles of your ether. And then I would have to argue that that's genuinely empty space.
Franklin, with such space that it's always discrete. It cannot have a continuum. And in physics, you have, besides of discrete spaces, for example, the set of all rational numbers, you have also the continuum of the real numbers. And these two things are quite different things. In fact, the rational numbers are embedded into the real numbers.
But I would argue that has nothing to do with physical space.
Yeah, well, physics is using both. It's using these rational, the discrete spaces, and it uses the continuums.
Okay, so what topology are you using in your theory, Hans?
I'm starting with a Hilbert space, but the Hilbert space itself uses the number systems, and I use the quaternionic Hilbert space in order to model to build the complete model. You cannot.
That doesn't answer my question. I want to know, what is your assumption about the topology of space? Is it a continuum, or is it some kind of a discrete topology that, or what? What is it?
It is in fact the combination of both. It is the number system of the quaternions is a continuum, and it has embedded in it the rational quaternions. It is a discrete space embedded in a continuum space.
All right, so you kind of lost me now.
Why? It's the rational numbers into the real numbers. That's the one-dimensional one. And the quaternions are just
Wait a
the
minute. You said
four-dimensional
the
ones.
quaternions are the quatern. So you're saying, I'm trying to figure out what mathematical system you're talking. Okay, first you have to have a topology, then you have to have a number system that goes with that topology. So you apparently have some kind of a separation principle. So it's Hasdorf separable, right?
Yeah, that's the set of the rational numbers. The rational quaternions are separable, and the continuum is the full quaternionic number system, which is like the real number system. It's a continuum.
Okay, so what you're saying is your mathematical system is the quaternions over the rational numbers. Is that correct?
That's the discrete space, and the
Well, no, over the rational numbers would be discrete. So you mean it's over the irrational numbers, over the real
the
numbers, the
irrational
real
numbers. The irrational numbers are if you
I
together
said
with
that wrong.
rational
I meant to
numbers
say
form the
real
real numbers.
numbers. The real number space, which is a continuum.
Yeah.
Okay, so
if
your
you take that
assumption
in
is
four
that,
dimensions, if you take that one in 4 dimensions, then you get the quaternions. Well, one dimension is a bit exceptional because that's the real part, and the other 3 dimensions are forming the imaginary part. It's a combination of a real number with a 3 dimensional spatial vector. That's a quaternion.
okay, so you have quaternions over the real number field, and that is a continuous number system. It's a continuum.
And
correct?
if you use the rational numbers, then you get the discrete quaternions.
Okay, gotcha. All right, so that implies if you're using the real numbers, that implies you're assuming that space is continuous.
Yeah, and you need both to do physics.
Well,
does that answer your question, Harry?
I think it merely confuses the issue because he's got two models. He's got a discrete model and a continuous model.
Yeah. That's right. I need them both because in the Hilbert space, the one of the Hilbert space is a separable Hilbert space, and the other Hilbert space is a non-separable Hilbert space. And these two, the separable Hilbert space is embedded in the non-separable Hilbert space.
All right, gotcha.
What's happening?
Gotcha. Understand. Okay. Now, see, my problem with your first sentence here is that you're making an assumption that you're using mathematical spaces. Okay, so you are assuming the mathematics of space right at the get-go. Okay, and now I understand what your assumptions are. Thank you. I don't know that anybody else did.
Okay, well, as long as you're happy, Harry. But
no, I think you ought to understand them too. And I think other people should understand what they are. But it's a bit complicated mathematically.
But how about to have Hans to walk us over those quaternions, but the quaternion algebra and kind of the ratio between physicality and his model and his project itself?
Well, I'm still highly skeptical about highly mathematical structures. But what you mentioned there, that there being like two levels.
What? Hold on. Why would you be skeptical about a mathematical structure?
Because mathematics are not structures. But here talking about kind of new mathematics. This is kind of important to realize, right? Mathematics fits to reality in a way. You know what I mean?
Right. Well, what Franklin is saying is, because I don't understand the mathematics, I reject the idea that the real physical space is described by that mathematics that I don't understand.
No, mathematics is something you stick on a chalkboard. Physics is like the chalk and the board.
Well, you don't understand the mathematics, so you're rejecting the theory.
Only what is mathematics is important, but through mathematics, mathematics is in general correct. I mean, all the time. But important, the problem is physics. They misuse mathematics to do physics.
Yeah, to say
And
that
physics actually requires particular form mathematics. And quaternions algebra seems to be that right form or close to that right form of mathematics.
well, when you start saying that the chalk is equations or numbers, that's where I have a problem.
I mean, if you really want to, you could do that. I mean, you could get into the molecules of chalk and the atoms, describe them with those formations, put the math there. But usually we do things, mathematical analysis on kind of macroscopic or kind of phenomenological level. But it's up to us to what scale we are going to go, how deep into the structures, or how high the structures.
Yeah, well,
I mean, but one thing should be sure, we have to sort for unique representations of nature on all scales. In nature, we have so-called golden relationship between all the adjacent or neighboring scales.
Well, I would assure you that
if the proper mathematics reflects that, I mean, really, we don't have to do the search for anything else. It will be tremendous change of paradigm, tremendous breakthrough in science and technology.
Well, I would say that the electron doesn't care what number system you're using. So it's a physical.
Okay, it does not, but we do care. I mean,
Yeah.
Why are you relativizing things, Franklin? I mean, I really don't understand that. I mean, we can get to your theory as well. You can have your theory very well supported, maybe not in the whole, but maybe a big chunk. So you will be just fine and happy.
Well, let's get on. So, I mean, another point that you're making in your mail here is that the Hilbert space can only support point-like particles that are specified by rational numbers.
The separable Hilbert space can only represent
Right. I was going to make that point. Yeah, separable Hilbert space.
Yeah, what is separate? Is there a non-separate Hilbert space that you're talking about?
Yeah, there are two of them. The one is the separable Hilbert space, and there you can put all kind of countable things, the countable sets in. And the non-separable Hilbert space embeds the separable Hilbert space, so the separable Hilbert space is in fact a part of the non-separable Hilbert space, but the non-separable Hilbert space also includes continuums. So if you embed the separable Hilbert space, you are in fact embedding all these discrete things that are in the separable Hilbert space into the continuums.
Well, that sounds a little bit like, the etherists who say the space is filled with these point-like ether particles. But between the ether particles, there is a continuous space. That is not. So
I mean, even continuous space has to be discrete. So I mean, really, we don't have to put it to the extreme, in principle, right? So if somebody of some mathematics comes to some kind of configuration combination that can somehow conciliate these two really kind of, incommensurable maybe concepts, then they will be just fine.
A continuum is nowhere discrete. A continuum is a continuum, and it is not discrete in no way.
But, I mean, it could be questionable, but my point is actually that we should not go, I mean, really that deep. I mean, so my question would be, to what extent is your approach, your method related to the Cantor's mathematics of infinity, of infinity?
All countable things.
Cantor.
Countable. You can count the elements into a countable space, and all aleph 0 sets are countable. RF1 sets are continuums. The real numbers you can no longer count. There is no way you can count a continuum.
Yeah, I was told in one of the presentations here. I heard actually that Cantor was kind of mentioning some kind of ether as I don't know, as continuum, whatever, in connection with his work.
I never have heard.
You never heard that.
Talk about ethers, but it is very good to know that you can embed a countable set into a continuum set, and that's what, for example, the natural numbers, or the rational numbers, the integers, and all those things can be embedded in a continuum, in the real numbers.
Maybe for all practical reasons.
No, but that's in fact one of the big secrets of mathematics that many people don't understand well, and it's very difficult to understand. But you need to have this difference between a continuum and the discrete number sets in order to understand that something can run faster. And a human that walks fast can surpass a slower one, and that can only be understood in a continuum, and not in a set, not in a countable set.
Well, let's go on with the thing that you're interesting that you're saying about point-like objects is that they only contain a very limited set of properties. Like they can have a position and a point in time, but pretty much not much more than that. Yeah. Now you're saying that the dynamics can represent more properties.
If a point-like object is allowed to hop around in a hopping path, then the hopping path at the end is forming a swarm, and that swarm can have all kinds of properties. It has symmetry. It has an extent. A point has no extent. It has a density. So it has many properties. An electron has many properties, but a point-like particle on its own, at a single instant, an electron is nothing else than a position.
Now, there was an interesting question on Quorum recently, which was, it said that if an electron is a point-like object, then how can they collide into each other? So are your point-like objects, can they collide into each other?
Well, the swarms can collide into each other. A point cannot collide into another point. At least that's not comprehensible aiming problem. If you want to have 2 points that collide into each other, it's impossible.
I got a question for you, Hans. In your opening, you were talking about the one-dimensional wave equation. And that was forgot the name. The solution of the one-dimensional wave equation is a hop, or what is that?
A warp.
A warp. No, wait a minute. I thought the warp was a two-dimensional wave.
No. There are no two-dimensional shock fronts. There are one-dimensional shock fronts, and there are three-dimensional shock fronts.
Okay, what's a one-dimensional? What do you mean by one-dimensional shock front?
It's a one-dimensional phenomenon, and it's behaving like a shock front. It's
what do you mean by one dimension?
If you take a long rope and you take jump with one end of the rope, then you see a hubble running to the end of the rope, and that's a one-dimensional shock front.
All right.
And if you have a three-dimensional one, then the hop is running in a sphere form. The sphere is extending.
And that
and
you're
at the
calling
same time,
warp.
and at the same time, the amplitude of that shock front, this spherical shock front, is diminishing as 1 over the distance from the center.
Okay, so the one-dimensional transient, which you call a
Yeah.
shock,
Yeah.
is analogous to the motion of a rope. And then you say that's called a shock. And then the warp is the three-dimensional.
No, the warp, the warp is the one-dimensional one, and the clamp, CLAMP, that's the three-dimensional one. And from that one, the amplitude is diminishing when it travels, because it has to extend in all directions, and it loses its amplitude. But at the same time, it deforms its carrier. The clamp is capable to deform its carrier, so it has mass, and the warp is one-dimensional. It doesn't deform its carrier, but it can travel huge distances, and that's what photons do.
Let me ask the question. What is the wave equation? Is it like a D'Ambler? It's a second order D'Ambler wave equation? I can't say.
It's D'Alembert's equations. The D'Alembert's equations, it's using the D'Alembert's operator, and it's a wave equation. And if you type in Google or Wikipedia for the wave equation, you find that wave equation as a second order differential equation.
Okay, but that's in quaternion.
Oh, you have it. You also have it in complex number systems. And
right,
and
is this in quaternion space now that you're using?
What I do is I have in quaternion differential calculus, I have exactly the same equation. I have a wave equation, and I have a second equation. It's quite similar to it, and it also have these warps and clamps as solutions.
Okay. That's interesting. Yeah. So in the quaternion space, you get two types of equations or two solutions, I think.
And the second one that has no waves as solutions. It only has these warps and clamps as solutions. While the usual wave equations that has both waves and clamps and warps as solutions.
Okay, now you need, in order to get a physical situation, you have to use boundary conditions. How do you apply boundary conditions?
Yeah, there is no boundary. It's completely isotropic in these views for these two phenomena. There is no, everything is isotropic or linear. The triggers, in fact, that thing what triggers the shock front is in fact determining what kind of solution will be used.
Well, that's basically a boundary condition.
That's a boundary condition. Yeah, you are right. It's a starting condition.
Okay, so you have a boundary condition that initiates the process. Okay.
Yeah.
So Hans, so your conclusion on our mail here is that physics is not so much a theory of particles, it is more a theory of mechanisms that determine the dynamics of a point-like particle.
Yeah, something must generate these hopping locations. The hop locations are not existing on their own. Something must generate and regenerate them, because these clamps are fading away. Their amplitude diminishes when they fly away. So they are very temporarily, and you need a huge swarm that is regenerated in order to create an electron. An electron is continuously regenerated, otherwise it fades away, because all these clamps are fading away.
Yeah, Hans, what is your email address? Just maybe initial letters of email address. I want to send you something and ask you something.
Hans van Leunen I'll put my email address in the chat.
No, I'm not. I'm not on the network.
Sorry.
I'm calling
Hans,
from home.
Hans van Leunen with points. Hans point van point Leunen at planet planet Earth point NL point
okay.
Netherlands.
Okay. Thank you. Sorry.
That's my email address.
So, but my response is, I mean, there's a lot of controversy over point-like particles. I think if Bill Lucas is here, he would tell you that there's no such thing as a point particle.
Yeah, I think there's not such things as these steroids because there must be something that generates them.
Well, I mean, I have a problem with point-like particles as a concept. You know, I brought up the wiki here about the spherical cow. Now, if you guys have not heard about that, you know, there's a joke that, you know, a farmer asks help for milk production from the local university, and then they start out by saying, well, we'll model the cows as spherical, right? And it's like, this is what tends to happen with, I think, point particles, in that that's a handy kind of simplification, but it really doesn't exist.
Franklin, that's why I need a separable helper space and a non-separable helper space, because in the separable helper space everything is point-like, and in the non-separable helper space things can be point-like and can be continuums. And if the separable helper space is embedded in the non-separable helper space, then the point-like things are embedded, are hopping around in the continuums.
I'm still not quite sure I understand, because like I was just saying, like if your fundamental particle or your point-like particle can't interact with each other, then how can they do anything, right?
Because their hopping is vibrating the continuum, and that continuum is making the link from the one particle to the other one. These continuums are connecting the discrete objects.
How can they connect? I mean, if the only physical connection I can see,
they vibrate,
collide into each other, right?
They vibrate or they deform the continuum that in which they are embedded. And embedding is they are hopping around in the continuum and they deform the continuum. So they feel they're hopping around on the floor, and this floor is wiping around, and if you two are hopping around, then they feel each other via the floor.
Well, there would still have to be some kind of intersecting finite size for them. I mean, even if I have a wave and I'm waving it back, particle, and I'm waving it around, but it can't actually interact or collide with any other particles, then it can't have any influence.
The particles don't have limbs. The only way they can communicate with other particles is via vibrations or deformations of the continuum that they are both hopping in which they are embedded.
Then what's the continuum made out of?
The continuum is a continuum. It's not made of anything. It is a continuum. It is either something point-like or it is a continuum. These two things exist.
But if it's a continuum, it must be made out of something.
A continuum is for example, the real numbers exist.
But only in your head.
Yeah. But also in reality.
No, not in reality. I assure you, empty space doesn't know anything about numbers.
That's not true. We have learned our numbers and our concepts from from reality. It's not the other way around, that reality has learned mathematics from us. We have learned mathematics from reality. We have derived mathematics from reality.
Now, mathematics is something that humans made up
Yeah,
based on reality.
we are smart. We are smart individuals. We understand and looked at reality, and we
But
came up. Well, these things are exist in reality. Separate things, discrete things, and continuums exist in reality.
well, I went on with my reply saying that I prefer my particles to be something that have finite size and a ponderable surface, like a hard little ball. So
Yeah,
this is the way I like to see that. Now, that's of course my personal opinion.
but a hard ball can never communicate with another hard ball without touching it.
Yes, exactly. That's my point. That the
Yeah.
only way that one hard little ball can communicate with the other hard little ball is by touching it.
Yeah.
So we can consider like the atoms in a glass of water,
Yeah.
or the atoms in the air in front of you, and we know that the way that they're interacting is purely through collisions.
And
So
what's in between? What's in between?
nothing.
Nothing.
That there's nothing that as the atom flies through the empty space.
I tell you, what's in
nothing until
between?
it hits.
What's in between is a
There
continuum.
is no empty space. There is no empty space. I mean, really, as I suggested before, we should not really go there into details. Kind of, let's see the merits of particular concept or construct or approach.
I mean, what's wrong with like electron being a hard little ball?
Cannot be. There is nothing. I mean, there is nothing static. Everything has to be moving and be described by movement. So electron is toroidal vortex described by the movement of those particles. Say continuum. I mean, for all practical reasons, kind of continuum. Whatever, no matter how tiny they are, whatever they describe that shape. And that shape then becomes that kind of maybe basic structure, maybe that separable, right? Separable element of separable space. The Hans is talking about. I mean, would be enough to get there. I mean, kind of really somehow to conciliate those aspects. Maybe not to. I asked what continuum. That can be again must be consisted of particles. But if I say okay, particles that are moving, I mean for all practical reasons they can consider as a flow, as something continual, some fluid, and so on. And but it's important that can create those shapes, those structures, that topology, and the topology then may become then element of algebra as something that I think Hans you have as part of the separable space, right?
Yeah, but a continuum is per definition non-separable. You cannot split it.
Okay, but it can create that separable the element of separable space, right?
It can only embed separable things.
Okay, embed, get created out of, right?
Embed,
what does it mean embed?
It means that you put a natural number inside a continuum.
Yeah, okay, but we are talking here about physicality, about physicality. How to relate those two things, and I'm offering that kind of explanation, something like to maybe help get out of it. So, if the continuous space, a non-separable space, can create those elements of separable space as those vortexes, then we are there, right?
A vortex is something that is behavior of a continuum.
It's behavior. It's a structure of the continuum.
You can have
a very complicated structure.
I mean, it's not. Just look at the smoker's ring in the castle in the container with smoke under pressure.
And that is the most complicated.
Everything is there. Everything is there. Just look for different scales, and everything is there.
I mean, you might as well say that the Mandelbrot figure is made out of, it makes up everything, which I have heard that as a theory.
Why not?
It's very complicated. That's why not. So, I mean, that's about as likely as a toroid, a Mandelbrot shape.
Yeah, but Mandelbrot, I think, is mostly discrete. at the end, it goes to a limit, and the limit is never there. It's like the series that you can create from rational numbers. If you take a series, a row of rational numbers that approximated another number, for example, pi.
Yeah.
It's
My
not a
point is that
rational numbers.
it's
You
just
can
highly unlikely
approximate it.
that anything is based off of that.
With rational numbers, you will never reach pi. But in the real numbers, you have pi as well as the rational numbers.
So getting back to my hard little balls, I mean, I think that everything you're talking about is just way too complicated. That if we start with the one little ball that we know about, which is like the electron and the positron, I mean, we know that those things exist. Now Slobodan may believe that those things are, you know, toroids, and I'll have to say that I don't know exactly what those
flow of such shape.
Yeah, flow of such shape, although I would seriously disagree that
creating such shape.
I would say that the only thing that we really know for sure is that electron exists and that positrons exist. And we know something about the properties that somehow they attract each other. These are the things that we actually know. Now,
but we would like also to know how they attract each other, and I offer that mechanism, and I sent that translation of that part of the book of Zyukovsky, and nobody's looking into it.
But I'll have to take a look at that. But I think it'd be simpler to say that if you have your space, as Hans started out with, which I prefer to think of as being completely empty and only containing the 3 dimensions of space, that you can fill that space with something like, say, electrons. So let's take our space and just completely fill it up with electrons. So that's one possible kind of space that we could have that's filled with things that we know about. Except that I'm pretty sure that if it was all electrons, our universe would be terribly lopsided. So my suggestion is to fill it half with the other particle that we know about, which is positrons. So we just take our space and we just fill it with electrons and positrons. I think that they will spontaneously, because of their attraction of opposite charges, they will spontaneously pair up.
Yeah, and on the other hand, the electrons are repelling each other. Huh?
Well, if you
never get close to each other.
If you stick an equal number of positrons, then they will stop repelling each other because all of the charges will be neutralized.
If you put equal numbers of them together, then you end up having nothing at all. You're only ending up with photons. They all convert into photons.
I just think you'd end up with a bunch of positron-electron pairs if you did that. Yeah, and that would spontaneously form up. See, this is in contrast to it forming, say, vortexes or your warps and your wraps and your hops, because I think that's very complicated. I mean, I would disagree that, say, the electron is made out of your warps and your hops.
Yeah, warps and clamps are the vibrations of the continuum. They are not particles. They are in fact, I call them objects, but they are vibrations of the continuum.
Yeah, well, I would disagree with that because I think you're going further than can be justified. Like I said, I think we can justify the existence of electrons, but science has not really been able to figure out that those are actually made of anything. There's no evidence that they are.
Because you don't want, Franklin, because you don't want to look.
No, it's not that we don't want to look. We've done lots of experiments.
In particular, you are not wanting to do that.
It's not a matter of me wanting to do that.
Definitely so, right? I mean, there is on my insights from following this chat, the exchange in emails, on forums, and so on, so on, so on.
I would love to know.
Why you're a young guy, look, Frank, you are a young guy, right? Have enough time of you, in your life. Just please use it well.
Well, I've just not really seen any convincing evidence that it's a toroid.
You don't want to look. You don't want to see.
I've looked, I've seen, and it's like I'm completely unconvinced.
No, you are not getting it.
I just
You
can't
don't
see how
want.
it can happen.
You have barrier. You have created barriers towards that.
Well, the only barriers I've created are what we know about physics. And the physics
And in order to know something about physics, you have to remove the barriers.
Well, that would be like the barrier of logic, and I'm not willing to remove
What
that barrier.
Losing it.
But I'm saying that, but actually I have no dog in that fight because I'm not willing to declare what an electron is. Now, if someone comes up with an actual reasonable explanation of what electron is, I'd love that. But so far, I haven't seen any.
No, you would not love that. I provided that, and you are not going to look into it. And this is my word in this meeting. Thank you. Sorry.
No, I mean, that continues to be my argument, and I've looked at that, and I've got at least 6 or 7 arguments against why vortexes are a bad idea. And you know, and unless someone wants to respond to those, then you know, I can only stick with what my reason and logic tells me, that those 6 reasons make vortexes impossible. So I continue to look at what that is, but my point is that I prefer to just deal with what we know about, which is that we know electrons exist, we know positrons exist, we know what they do, and that it's much simpler if you can start your physics at that level rather than try and go at some, like you say, continuum, but then you have this nasty problem of, well, what's the continuum? Now, if you just started with blank empty space, then you don't have that problem because there's obviously nothing in that blank empty space. As I think Hans would agree, would be like the continuum, but it has no properties.
A continuum can be flat, and then it is what you call empty space. But if a continuum is flat, then there's nothing in it, and as soon as if there is a vibration, for example, such a spherical vibration like a clamp in it, then it's no longer empty.
No, I think your space, you're still having to deal with that problem that your continuum still has to be made out of something. It still has to have some properties.
No. The continuum is a continuum. No, it's a field, and all continuums are behaving along the same kind of equations. They're behaving the same way, and what can be different is what triggers them, what their start conditions and their boundary conditions. But the equations that regulate, that control their behavior are all the same.
Yeah, but the question is, what is the fabric of that continuum defined of? What is it made of?
See, I would say nothing. Now, I've had a lot of discussions about this on the emails, that people objecting to my idea that the continuum is really nothing, but that continuum only exists between the particles of my ether, which is very small, which is almost nothing. But
yeah,
and it's only there to provide elasticity to the ether particles.
I have made it myself easy because I started with the Hilbert spaces and what can be in those Hilbert spaces. And these Hilbert spaces support the number system, quaternionic number system.
But I start with...
And these things together make a theory. And in this theory, you can let play a lot of things. And there, these continuums exist, and there, these point-like things exist, and there you can create things that look as electrons and behave as electrons and as quarks and all those things.
Well, I think, and in contrast to that theory, you know, I don't start with Hilbert space. I start with completely empty space. And then I drop the particles that we know exist into it, which is electrons and positrons. So I have bypassed basically a lot of these basically bootstrap questions.
Yeah, right? But then you're running into problems.
And what problems do you run into there?
that's the restrictions that your environment will put onto you, what you can do and what you cannot do.
And those are good because space has a lot of actual restrictions.
Yeah.
Space has things like permittivity, permeability. Space has to support magnetic, electromagnetic fields. It has to give some reason for why inertia happens. It has to support gravitational fields. So
that is what these Hilbert spaces are putting you in. The Hilbert spaces are a kind of environment for your universe.
But I don't need. But I would argue that a Hilbert space is not necessary.
Well, they regulate a lot of things. They put a lot of restrictions. For example, they regulate that you can only work with real numbers, with complex numbers, and with quaternions. They don't accept other number systems. And you can work.
I would continue to argue that space doesn't care about your number systems.
Yeah, but Hilbert spaces do.
Yeah, but I would say that space and the piece of chalk I'm holding in my hand don't care about that.
Yeah.
So that's something that you've basically made up in your head to describe physics, but it actually has nothing to do with actual physicality of space or particles.
Yeah, you're starting from a very high level. If you understand an electron, you still don't know how to build an airplane. And if you go downwards, then you don't know how to build an electron and how to build a molecule from an electron, all those things, how to bind these things.
I would argue that if you're starting your theory based on something like the electron, then I'd say you are on much more solid ground than starting your theory on something like Hilbert space or a continuum.
I wouldn't, if I had to start with an electron, I wouldn't know how to make, for example, a molecule. How do you bind electrons and nucleides into a molecule? There's no way to reason into that direction.
But sure it is. I mean, if I start with an electron and then I have my opposite of the electron, the positron, then if I take two positrons and an electron, that will make a proton. So that's a positive charge particle. Now, if I take a proton and I throw another electron around it, that would be a hydrogen atom. Now, your most basic molecule,
proton is created from three kind of quarks.
No, that would be wrong. Actually, it would be it's because I don't think quarks exist. The three particles in a proton are two positrons and an electron. Those are the three. Those are the three observed.
You create your own world, and we know physics at this moment knows that the nucleides, like protons and neutrons, are generated, are constructed from quarks.
Well, I would say that it's actually physics which has created their own world. I mean, how can you tell which world is correct? Now,
well, go to CERN and look at those big machines and see what they do and what comes out of it.
And has a quark ever come out of those machines? The answer is
they regularly come out of it, and you better not stay in the neighborhood of them because they're killing you.
A quark has never come out as a separately measurable particle ever.
They come out as baryons.
And they've been trying.
They come out as baryons and mesons, but not as an electron and not as a positron.
Now, the only thing that comes out of the particle accelerators are positrons and electrons.
No.
That's the only thing that comes out.
Baryons, mesons. You have a large zoo of small particles that comes out of these nucleides.
Yes, most of them are very short-lived, and they all decay into positrons and electrons.
No.
Every single one of them.
They decay into photons at the utmost.
Well, there's gamma rays, which are photons. But every single particle that comes out of them is a positron or electron. They're not stable.
Mesons and baryons are stable. Quite stable.
The only stable particles are electrons, protons, and neutrons inside of atoms. But aside from that, everything else decays. There's actually very, very, very few stable subatomic particles.
That's true.
But
that's a question of more or less time.
But did I answer your question of, if you start with an electron, then how can you explain a molecule? Because once you get to the hydrogen atom, you just put another hydrogen atom next to it. They mate together due to opposite charges, and there you have your basic molecule. Ta-da! So that's how you can explain, you know, how molecules form starting from just the electron.
How do they bind? How do
by
they stay together?
By electrostatic force.
No.
It's got a positive charge. It's got a negative charge. You know, your individual hydrogen has got a positive and negative. So it's a dipole. So if you stick two dipoles to each other, the positive will naturally attract the negative, and voila, they will mate together.
Nobody will believe you.
Well, do you believe me? I just gave you a perfectly sensible, reason-based, nothing on more than the geometry of dipoles and the Coulomb force that would say, yeah, if you just put those two things together, they're going to clamp together.
No, but right? That's not that simple.
It is that simple.
No.
It is. See, this is the other funny thing when I tell people that. It's like they say, it's not that simple. It's like, well, what's wrong with simple? I thought science likes to find simple answers. Or do you like to find more complicated answers?
The reality is somewhat more complicated than just connecting positrons and electrons and build molecules from that.
Why not? That's I would, you know, strongly argue that that is exactly what it is. But what's complicated are all this quantum physics.
Okay. I thought that I'm not going to say anything, but Frank, when you are going to stop to observe this, conference sessions to promote your theory all the time with the same words, with the same objections to others' proposals, comments, discussions, whatever. When are you going to do that, please?
To do what?
To stop misusing, usurping this medium and these opportunities, these sessions, to all the time keep promoting your theory and be so kind of antagonistic to whatever suggestions, proposals are going around. All the time asking questions to get back to your stuff.
Well, this is a science chat. This is an open discussion between everyone who's participating here.
It should be it shouldn't be always on the same topic. It shouldn't be always that we return to your topic of Apollos or whatever.
If it's relevant, then that's okay.
But there are other things that are relevant. They're much more relevant than that. As a moderator, you should open the medium for others and be attentive and kind of, help in that sense. Not all the time bury everything and then just stay with your theory.
No, it's a debate. So Hans has.
We should not have all the time the same debate. We should move a little bit.
Well, there's like a debate between you and Hans. So we have that kind of debate. And actually, everybody basically does that same thing.
I'm quite close to Hans' the approach. We should look for commonalities, Somehow, communal things, something that can support each other, overcome the barriers of using different words, different terminology, and so on and so on.
Yes, that's why I brought up the similarities between, say, ether theory and the commonality between continuous versus non-continuous.
Yeah, just to mention your 7 points, whatever. But when I started to responding to your first point, or maybe most important of it, you are not getting back to discussion. On email, I mean.
Slobodan, everyone has the right to object or disagree. just because somebody's the moderator and they object or disagree doesn't place any more weight on that or create an objectionable environment. If we're baiting and debating, and I use that term thought-provokingly, then we should be looking for everyone's thoughts and feelings on it, so that there are things that we cannot yet measure because we don't understand that they even exist. But it's the gaps in our understanding that are thought-provoking that bring that out. And when someone objects like that and says, I don't believe that, everyone on the forum has the right to do that. But what it is it's a place for us to be thought-provoking, to explore why is that true or why is that not true. And I think that's a good thing. Would you agree?
But Franklin is using objections of whomever, in particular himself, to get back to his theory. I would have many objections to the structure, say official structure of atom and things like that. You know? no problem, you know. But somehow I really I don't understand that. All the time getting back to his point.
Well, you get back to yours all the time, brother.
Yeah, I mean, I think that's perfectly fine. I mean, as a moderator, you know, I'm supposed to remain kind of neutral.
Yeah, should be a little bit more maybe than me, right?
But since
at least so.
But since I'm obviously have my own own theories, then yes, I will obviously bring them up, because I'm trying to find, you know,
look for another forum then, right?
What's the problem with my theory? I mean, if you have a different theory, then I want to hear why you don't think that my theory is correct. Now, the only way I can find that out is by saying, okay, well, this is what my theory does, so what's wrong with that? So, and you do the same thing. I mean, I think everybody in the forum here is invited to do that.
Everyone should look what is wrong with his own theory based on this kind of discussions, without really expecting that somebody is going to attack it directly and tell him this. No, when I say there is nothing without movement, there is no electron without movement. The electron cannot be ball. Because electron has been ball, traditionally, they had to postulate many things, many wrong things. They were looking for magnetic monopoles, for example. And of course, magnetic monopoles exist, but it has to be formulated differently than with those singularities as this guy Dirac did at the time. You know what I mean? So one has to look, instead of maybe spending too much time in promoting their own theories, people should look around, read, get back historically, look where things has gone wrong, and help correct.
Well, I couldn't agree more. The question is, how do you do that?
I agree that there is a lot wrong with current physical theories. Most is right, otherwise the planes would fall down and there wouldn't be any computers or automobiles or so. So much of physics is right. A few things are not correct. And I think that everybody here might have its own beliefs, but I think none here has a complete theory. Nobody. And most of physics is not wrong. It's perfect to a certain extent. Where it fails in most cases is in its foundation. It's in its fundamental approaches. Physics is good in describing how things work, how things are going on. And you can use those descriptions in order to build things, to build computers, to build atoms, to build planes and things like that. But physics is not good in explanations what the origins of things are. And I think that's part of where we in this discussions are after. What is how is reality constructed? How does it work? Why does reality behave so coherent? And at the same time, it's so chaotic. It's completely controlled by stochastic processes. How can I understand that something that's controlled by stochastic process also works so trustworthy, so coherent? That's what we try to find out.
Yes,
Point
Because
absolutely.
well
it is
made.
not stochastic.
Yeah, we're doing a lot of discussion in that area. So we discuss a lot of things like, for example, we've been looking at what electron is made out of. So Hans definitely has, and Slobodan definitely have particular ideas of how electrons are made. Now, I don't think we should be afraid to, in the discussions, to say we directly disagree with something. I think as a researcher myself, I mean, the most boring thing in the world would be is if everyone just agreed with me, because then I would not learn anything. If no one presented any challenges to what I was saying, that would be like the most boring thing in the world. So I think that, when people say things that they disagree with, and I've been doing more of that, obviously, that just say, I don't believe that's true. And give specific reasons why they don't believe that certain things are possible.
Well, I don't understand. Well, I may not understand Slobodan's definition of the electron. I am very, very much looking forward to his further explanations and learning his perspective. Although I don't agree with it at this time, I can't explain why. I disagree, but it doesn't fit the paradigm and the perspective that I come from. I want to see his paradigm, and I want to hear what. And the same with many other of the explanations on the group. I really want to learn and see what they have, and it's by this give and take that I begin to see the dynamics of the academia there. And if we didn't have this give and take, I wouldn't know where the boundaries and where the fences are in the definitions of this, while a group tries each theory back and forth and explains the ups and the downs of it.
Yeah, I think.
Could you please tell your name? Sorry, I could not recognize your name. The person that just spoke.
Oh, you talking to me, Slobodan?
Yes, yes.
I am the tall, funny-looking guy from the Extraordinary Technology Conference. I am John.
Okay, then
yeah.
Your name sounded me very kind of familiar, you know.
You remember me now, my honored brother?
I don't know. I'm okay, Kerky or what, right? Okay, great. So I would ask Franklin or maybe Hans. I just sent an email to Hans.
Yeah.
With a link to those translations that I made from the book of Vasyukovsky, you know. And I also relied on him, as you remember, in my presentation last year about magnetic monopoles as gearing elements of unity systems, right? You remember?
I just saw your message and I will respond.
Yeah, so I just reminding John about it. Okay, thank you. So,
I'll do my best.
Good.
But you are translating from what language are you translating now?
From Russian.
From Russian. I cannot read Russian.
No, I have translated some parts, some sections, some chapters. You know, I mean, you guys, I told last year in Albuquerque, to all guys, I said, for last say 80 years, Russians have been translating everything what was published in the West. Now, I said, and I'm telling you now as well, it's high time for people from Western Hemisphere, from US in particular, to start translating from Russian.
I agree.
Yeah, thank
immediately.
You.
I was reading during my student time, I was trying to read Russian books, but my Russian was very bad. And I had to wait a few years until they were translated into English.
Yeah, one more thing. I mean, the Google service is pretty good. In particular, if you feed him initially with some corrections, at least it was my impression. So currently, I'm really satisfied. I pretty much rely on the service. At least kind of not to type, copy, paste, and then correct, and then get back. And I have feeling, the more I provide better feedback or good feedbacks, the more correct initial translations I get. I don't know to what extent it's real, but I had such impression.
The reason that the Russians are so good is that they are very good mathematicians.
They're good workers, you know. You will see this book, Tchaikovsky's book, out of maybe 200 references, maybe 160 are from the West, you know.
I've learned a lot of physics from.
They had everything. They had working. They had kind of working freedom, much better than the United States, you know.
I have learned a lot. I have learned a lot of physics from Landau Lifshitz. You know Landau Lifshitz?
No.
Yeah, it's like I'm now 76, and they were from my student time. They wrote the best books on physics at those times.
Yeah, if you had read those books, then now you at least help me with my translations. You could really get some. And I think particularly two of us are close. Somehow, kind of. I mean, okay, I would not repeat myself, but I think we should go really kind of the commonalities toward new things, and then look into our approaches based on that, and somehow, you know, look for deficiencies of say our insights and theories ourselves. I mean, not waiting for others to attack you. I mean, it's enough just to be attacked just small percentage or some small part for somebody to maybe get discouraged and things like that. Everyone should actually look to correct and improve his own.
Well, I wouldn't consider people question your theories as, say, an attack. That's kind of like a personal thing. So it's I think it's better to leave the personal feelings out of it, and if people are objecting to your theory, I mean, it's like Hans, you know, objected to my theory because he couldn't see how you could build molecules out of electrons. So, you know,
so you have please look. Who is going to forward this? I mean, I don't have the list of the addresses of the people that are currently in the meeting. I see you are talking about some material that Hans has sent and so on. So I sent to Hans this time, so he may forward to others, or maybe you, Franklin, just, you know, maybe to, and maybe I should have put the link from the maybe chat from maybe 1 month ago, where we actually were going over the parts related to the structure of atoms.
Yeah, I think you're on most of our email list, although for anyone
yes, on email list, but somehow, okay. Huh?
For anyone who's listening, I will often forward these messages to the googlegroups.com, which is publicly accessible, NPA Relativity, googlegroups.com. So you can get a history of these messages that I have been forwarding to that group. So that's one other place. Also, we discuss things on the CNPS forum, but a lot of discussions still happen on these email lists, just back and forth. And actually, this particular discussion was actually just between me and Hans. So I'm not sure why Hans decided to just send it to me and not everybody. But
okay, I was sent. I was okay.
I have not the address list of the whole community, so I mostly send it to you, Franklin, because I hope that it was somehow distributed. But I also don't get the messages that are sent to you, so I'm maybe not a member of your mailing list.
Well, usually what people do is that they unwillingly get on the mailing list, and then they just do reply all, and everyone likes to do reply all. But I'm not sure what you do to actually get on the list.
Now I hate reply all, because next thing is that I get a lot of spam.
Yes, that's exactly what I deal with every single day. There's like 23 to 30 messages from this list.
I get about 100 mails per day, and about 50% of it is spam.
Yeah, but I don't mind getting the mails on science. I mean, I will briefly read through the ones that I'm interested in,
yeah.
and And like today, so you have reached your goal of distributing your mail because we made the whole meeting about that. So,
Well, sometimes the preponderance of mail that comes in can be overwhelming, especially when I get 600 to 700 a day. I don't mind any of the reply alls because, as Frank said, we have a chance to sort through them, and it's very thought provoking. Even when in the middle of the night I don't have anything else to do, I can go over those emails and spend some very thought provoking time on subjects that I may have never considered pondering. So I think it's a good thing.
yeah, it's just something you got to
John,
do.
what is your address? Sorry. Could you tell your address me, please?
Oh, me, Slobodan?
Yes.
I already get everything you said. It's servant@wt.net. I'm already on all the lists that everybody sends. been for a long time, many years. It's rarely I ever participate or speak up. I like to listen mostly.
Yeah. Okay. Okay. Good. Thank you.
But thank you for asking, my honored brother.
So your family name is Middleman, right? Middleman's. No. What is your family name, Joe?
Pardon?
What's your family name? I mean, to save me searching. I mean,
my family name?
Yes.
Fiala. F-I-A.
Oh, okay. Good. Yeah. Okay. Sure.
Yeah.
I see.
Okay.
Thank you.
Yeah. You've met my father, and in fact, we had lunch together a few years ago when you presented at the Extraordinary Technology Conference.
Okay.
You've met my son also. You chatted with him on the inertial propulsion space drive.
Yeah, how was it exactly? Oh, yeah, okay. I understand now. Yeah. Yes, good, thank you. Sure.
Okay, we're getting towards the top of the hour here. So we've had, let's see, I'm sharing my summary here. So why don't I go over our summary here? So we initially started out with Hans, and initially I wanted him to describe his email, but we got a description of his theory, which includes shock fronts, warps, and hops. And Hans has published a lot of stuff on his theory. He's got his own wiki university. So if you want to know anything more about what Hans is talking about, he's got all kinds of stuff. Now, as part of that, one of the things he mentioned was that that if you have a space and it's filled with something like some kind of structure, you need to justify how that is formed. So, but one of the things he mentioned was toroids, which is apparently Slobodan's favorite topic. So we did have a discussion about toroids. So Slobodan, gave us some explanations for how these things may spontaneously form and why those can be justified. But then we kind of got into a discussion of what is space itself, and actually, what is the relationship between numbers and mathematics and space? So, is space a mathematical construct? Is it a real construct? What is the difference between what the math is doing and what the actual reality is of space? So it was still kind of difficult to tell what was what, and that some people like to just describe space in numbers, although that itself is not the actual physicality of space. Then we can get into the discussion of how point particles may work, and that they would have limited properties. So once again, as Hans pointed out, I think physics, mainstream physics, does describe a lot of what goes on in physics correctly, but we do have this problem with trying to find out what the whys are. You know, it's like we know exactly how these things work, but we don't know why they work. We can describe them empirically with formulas and predict the results of our experiments, but yet still not have any idea of, for example, where the electron comes from. And so Hans's theory, I believe, does explain where those electrons come from, and we heard some interesting things about like how the electron would disappear if it wasn't continuously resupplied. And then we had a little bit of debate about, you know, about his theory in general. So we did have some questions about, say, my role as moderator. Now, to clarify, it's like, I don't believe that I could ever be, say, a neutral moderator. I'm more like Geraldo Rivera, and I will ask the pointed questions. Now, obviously, my questions will likely come rooted out of my own biases, but I think it's always good to challenge other people's theories. And since, of course, I know my own, the reason why I'm challenging, say, Hans's theory is because I see it being more complicated than a competing theory like my own. So as Slobodan had noted, that I will keep bringing up, say, my own theories as a challenge to other theories. And I think that's okay.
I think it too. It's okay.
I think
That's
okay.
very okay.
You know, so I get a chance to explain, you know, the questions that like Hans has. You know, he asked a very interesting question, which is, how can you build everything out of just like an electron? You know, how can you explain a molecule? So, you know, I shared that, and I may not have never even thought of sharing that if he didn't ask. You know, and in that process, you know, it was a challenge for me to say, okay, well, what do I know about my theory, and how can I explain that in the cleanest way possible? So I can kind of add that now to my list of things that go along with, say, my theory. So that helps me, and I think that's an interesting point for everybody who's listening to the conference about, you know, how that works. Although I'm still surprised that why everyone thinks that because I get this quite frequently, which is that's too simple, and I go, how can it not be too simple? It either works or it doesn't, right? So. But I think that will be the last word in this conference. I thank everyone for participating today, and hope to see you next week then. All right, so that will do it for today's conference.
Thank you, Franklin.
All
Thank
right.
you, Franklin.